how does a BJT differential pair extract a microscopic signal buried in massive electrical noise? Imagine two sensor wires carrying a tiny biological heartbeat, suddenly overwhelmed by a massive power line voltage spike. To fix this, we tied two matched transistors together at their bottom terminals and connect them to a component that strictly limits the total system flow to a fixed amount. This is a constant current source, and it forces these transistors to share a finite budget of electricity. When a massive electrical spike hits both transistor inputs at the exact same time, the tail source refuses to let the total current increase. The flow stays balanced, and the noise is completely ignored. But what if we introduce a tiny signal, raising one input while lowering the other? Because total flow is capped, the transistor with the higher input voltage actively steals current away from its partner. This uneven flow passes through the top resistors, translating a microscopic shift in current into a massive, readable voltage difference. So what happens to that original, fragile biological signal that was completely buried under the power line spike? The biological signal emerges from the circuit perfectly amplified and crystal clear, standing alone as a readable output. Meanwhile, the massive electrical interference has been completely erased, filtered out by the elegant physics of current steering.